Well, welcome back to NRM 435 GIS Analysis at the University of Alaska Fairbanks. Here we have another linear referencing application where we have a geodatabase with trap lines and a table of trapping data. So the geodatabase contains a line feature class representing small mammal trap lines, and each line is sampled once a day, where half the lines are sampled in the morning and the other half are sampled in the afternoon. And then we have a table of small mammal live traps set every 100 meters. And what we want to do is create an output table of all trap locations where at a trap there was a small mammal capture at least 4 times. So for example, on this trap line at this distance, 4 times a mammal was trapped. At this trap line at this distance, 5 times a mammal was trapped. So it's another linear referencing problem. So our first step will be to take our lines and measure them in meters. So since our table we have different line IDs, we'll have a unique route or measured line based on line ID. So the first thing is we'll measure or calculate the length of each line in meters. So we'll add a field for meters, and then calculate the length of every line in meters. So calculate geometry in meters. And then we can use the Create Routes tool to create a measured line based on the line ID and its length in meters. So that gives us 22 lines that are measured in meters. So let's hatch these lines so we can see that they are indeed measured in meters. So we'll put a marker every 100 meters. So for example, here's our first line, line 101, 0 meters, 100 meters, 200 meters, etc. So our next step is for every trap location, determine where it is on the measured line. So we can use the Make Route Events Layer tool to create virtual points from our 180 rows in this table. So after running our Make Route Events layer, we've got our virtual points. So for example, this is on line 101 and it's at a distance of 200. So this is line 101, here's the distance 200. So that's where that location is. The next one is on line 101 at distance 400, so it should be at this location, and it is at that location. So then our final step is, are there locations where there's been a frequency of more than one trap event? So we can use the frequency tool to determine that. So we had 180 traps, so if we look at our frequency statistics, it should sum up to 180, and it does. And then we're interested in all those locations where the frequency was above 4. So if we sort descending, so here's a location, line 105, distance 500, there were 5 trap events. And at line 104, distance 900, there were 4 trap events. So we could do a definition query on our table. Is the frequency greater than or equal to 4? And then if we open up our table, we have those 2 rows that meet our criteria.